10.1 today. Basically what this chapter's over is areas of shapes. This first lesson is over rectangles and parallelograms. I have a goal written on the board. You guys can go ahead and write that down. I'll give you some time. And as you're writing that goal down, we need to talk about something that basically a review. Before we get too deep into the lesson, we need to review our templates for our 30, 60, 90 triangles and our 45, 45, 90 triangles, because those will be coming back this lesson. And by the way, my handwriting's not perfect, and it's going to be kind of tough for me to draw because I'm using an iPad to do this. But we're going to do the best we can. As you can tell, I'm struggling here just to draw triangles. All right, that's as good as we're going to have to make it here. So first of all, let's start with the 45, 45, 90 triangle that I've kind of drawn on the right, and I can show that it's a 45, 45, 90 by putting these markings in there. My hypotenuse, or I guess maybe I'll start with the legs. Both legs of my 45, 45, 90 triangle are x, and then my hypotenuse is always x root 2. And over here on the 30, 60, 90 triangle, this is where people have had the most trouble, because you can memorize the template all you want, but if you don't know how to actually draw it, things get messed up. And a lot of people on our test, when we did this test, messed up just on the drawings because either they made their 30, 60, 90 triangle look like a 45, 45, 90 triangle, or they just labeled it wrong. They couldn't figure out which leg was which. So the small leg, and I've drawn it smaller than the other leg, that's x. The second smallest leg, or I guess it's the largest leg, is always x root 3. And the hypotenuse is 2x. And then people kind of struggle to figure out what these are actually labeled inside. Well, this is my smallest angle, so I'm going to label it 30. And that one's 60. We will need those for this chapter, both of these templates. So that's just a little bit of a warm-up for us. Make sure you have both of those written down on your paper, drawn better than I could, hopefully. And we're going to get right into this here. Any side of a parallelogram can be called a base. It doesn't have to be at the bottom. A lot of people think the base has to be at the bottom. It doesn't, because you can rotate the parallelogram however you want and make any part of it the bottom. The length of an altitude is called the height. We've talked about altitudes before, and that's the most basic definition of an altitude, how high it is. And just like on triangles, we always said the altitude has to be perpendicular with basically a side of a triangle when we were talking about triangles. Same thing applies here. Height has to be perpendicular with a base. You get to pick the base, but it has to be perpendicular with that. So basically what I'm saying is it has to be perpendicular with one side of the shape. Area of a rectangle. That's pretty straightforward. You guys have done this one before, I hope. Area of a rectangle is just base times height. A equals BH. Area of a rectangle is base times height. Some of these formulas that we get into, you guys are actually going to get a formula sheet for tests and for the semester test even. But that one, hopefully, is one that you guys don't need a formula sheet for. And also the area of a parallelogram. I hope we don't need a formula sheet for that one either, because it's the same thing. And you might be thinking, how can it be the same thing? Well, I'll try as best I can to explain this, but it's kind of difficult unless I had something to, like, if I was actually there in class, it would be pretty easy to show you. But if I were to take this picture here, the one that's on your screen, or on the smartboard, if you were to take this picture, and you were to take a scissors and actually cut it down this dotted line, that dotted line right there, if you were to cut it down there, and you took this piece and shifted it over to this side. Here's a couple things that would happen. First of all, this side would match up perfectly with this side because not only are they parallel, but they're congruent. We've talked about that with parallelograms before. And then also, well, maybe I'll just show you. This is what it would look like. If I took this piece and I moved it over here, it would make, if I were to just get rid of this, I'll see if I can kind of get rid of it. It would make a rectangle, basically. A parallelogram is just a rectangle that is cut and moved over to the other side. And I don't know if I did a great job of explaining that. Probably not. But maybe if the sub wanted to stop and try to explain it a little bit better than I could, he could do that. But this piece right here could fit in to this side over here if I were to cut that out. Maybe pause it and just check if they are understanding what I'm saying. All right. So as we move on here, as you can see, we already have a 30, 60, 90 triangle right here. And you can tell that it's a 30, 60, 90 because we have that 60-degree angle and we have a right angle. So we are going to use our properties of 30, 60, 90 triangles to basically figure out what this height is. Because when we figure out what the height is, we have base times height. Now, how do I know I have base times height? Well, if this is 18, then this is 18, and these are perpendicular. And that's what I just said. They have to be perpendicular for it to be an altitude or a height. So that's what we need to do. We need to basically figure out what our height of our parallelogram is if this base is 18. So how would we do that? Well, we could use Sohcahtoa. That's going to be a more difficult way of doing this. I'm just going to look at my 30, 60, 90 triangles. I know that if the hypotenuse is 12, and this would be my hypotenuse, that means that my small side is always half of that. That's what we wrote up at the top of our page. I'm going to highlight it. That's what we wrote up here. We wrote that our hypotenuse is 2 times as big as our small side. So that means that this side right here must be 6. And if that's true, we said the leg of our triangle, as you can see at the top of our page here, we said it was x times the square root of 3. That means we're taking our 6. I'm going to erase my circle there. 6 multiplied by the square root of 3. Now we've got an altitude and we've got a base. We've got 18 times 6 root 3 is our area, because this is basically our base times height. Now if you do that on your calculators, you're going to get a decimal. I'm going to let you guys try it because I got to try it over here too. I don't have it yet. So it looks like, oh, and by the way, it actually wants us to do perimeter too. We'll go through that in a second. But our area is going to be 187 inches squared, about. So this is 187, and I'm going to say inches squared, because remember when we talk about area, our label has to be in square inches. We also have to find the perimeter. I'm going to erase my formula here so I can do that down here. Perimeter, again, is just, I think we've talked about this plenty already this year, but it's the outside lengths of all of our sides added together. So we'd have a 12 plus a 12 plus an 18 plus an 18, because opposite sides on a parallelogram are congruent. So what does that give us? 60? And I'm going to label that inches. Not inches squared, but just inches. Maybe pause for questions on that right now, and then we'll move on to the next one. The next one is a 45, 45, 90 triangle, so we're going to use what we know here. First of all, if this side is 7, we got to know that this side is 7. So we're just filling in opposite sides at this point. Basically, what that tells us is that our hypotenuse on our 45, 45, 90, which we said, and I'm going to highlight it again up here, is x root 2. So I'm basically going to set x root 2 equal to 7. So let's do that. X root 2 equals 7. Divide both sides by root 2. Divide both sides by root 2. We would get x equals 7 over root 2. And then I did tell you guys to rationalize this for the last test. So we might as well do it now just for a little bit extra practice here. Rationalizing means I've got to get that root out of the bottom. So I'm going to multiply it by root 2 over root 2. 7 times root 2 on the top is just 7 root 2. And on the bottom we have a 2. So that would be an answer for that test that we took. But, and we can't simplify the 7 over 2 at all. But that is basically what we're going to have here. 7 root 2 over 2. And that's also what our height would be inside there. Now, do we have a base and do we have a height? Well, the answer is yes. We know that this whole bottom base here is 14 because that's what the top is. So if we took 14 and we multiplied it by 7 root 2 over 2, we would figure out what our area is. I'll let you guys figure that out. And what I'm getting is approximately 69 yards squared. Make sure you're squaring yards again. Perimeter. Perimeter again should be pretty easy. Perimeter for this one would be 14 plus 14 plus 7 plus 7. So I'm getting for my perimeter 42 yards, I believe.